Hello, on this video I'm going to talk about C++ pointers, and for that let's go take a look at some code. Alright, so first I'm going to create a variable called age. I'm going to assign 21. So when you create a variable like that, int age 21, you're going to get a memory space where you're going to store the value 21. And the memory space that an integer uses in C++ is 4 bytes. So therefore, you're going to get something like this. And these 4 bytes right here are going to be used to store the value 21. So 21 is going to be stored on these 4 bytes right here. Now, how do I know that age needs 4 bytes? Well, that's very simple. So if I print the size of age, the program gives me 4, and that's in bytes. So I know that the size of an integer is 4 bytes, and therefore when I declare a integer variable like that, you're gonna get 4 bytes in memory, and the value 21 is going to be stored on these 4 spaces in memory. Now, each space right here has an address. So how do I know the address of this space and this space and this space, so on? So if I want to get the address of a given location, all I have to do is to put the ampersand here, and that will give me the address of that memory location. So if I run this program, the address of age is this large number right here. Now this number is a hexadecimal number, and that number happens to be the address of the first byte of my variable. So my variable int age takes 4 bytes. So this hex number is the memory address of this byte right here that's in memory. Now these bytes will have a different address and different address and different address. But all we care is the address of the first byte. And the reason is, if we have the address of the first byte, then you can print the entire variable, or you can have access to the entire variable, because the variable, we know it's 4 bytes. So we know that this variable age is made out of this byte, which is the first one, plus 3. So all we care is the address of the first byte. Now, if I run this program again, I'm going to get a different memory location. So if you compare this number here that we had before with this new number here, it's different. And the reason it's different is because there are hundreds, if not thousands, of programs writing constantly to memory. And every time you ask for some memory, you're going to get most likely a different memory location, because that memory that you got the last time now is being used by another program. And you can do this again, and then definitely you're going to get a different number. Almost guarantee all the time will be a different number. Alright, so let's move on. Now we know that there is an address here, so I'm going to put this together. And now let's talk about the pointer. So I'm going to print age here. And now let's talk about pointer. A pointer is a variable that stores an address. So to create a pointer, first I need to know what kind of data type the pointer is going to be pointing to. And my data type in this case is going to be an integer. And then to declare the pointer, I'm going to put a star and then the name of the pointer. In my case, the name of my pointer is going to be my PTR4 pointer. So this is how we create a pointer. The star can be close to the int or can be close to the variable name. It doesn't matter. It's all the same. And then I'm going to point this to somewhere. So I'm going to point this to age. But I cannot point to age because age is the value that's being stored right here inside this 4 bytes. So inside this 4 bytes, I have the value 21. If I just point the pointer to age, I'm pointing to 21. I cannot point to 21. I have to point to the actual address of the first byte. And in order for me to get the address of the first byte, we need to use the ampersand. So the ampersand gives us the address of the first byte of age, and then after that we can access the entire variable. So now I have a pointer pointing to age. And if I print the my pointer, I'm actually going to print the address of the first byte of the variable age, which would be this number here. Now, it's not going to be the same number because, again, every time you run this program, you will get a different address. Here is when I display the address of age. And if you compare the address of age with the address of my pointer, they're exactly the same. And that's because my pointer is pointing to the age address. Now, with that, now that we have the pointer, we can access the value that the pointer is pointing to. In order for me to access the value, I'm going to put the star right here in front of my pointer, and the star is going to get me the value where this pointer is pointing to, not the address, but the actual value. So if I run this program, you get my pointer. If you just print the my pointer, you get the hex value. But if you display the pointer with the asterisks, then you actually get the value of the age. So in other words, my pointer now is pointing to the age address, and if you put the star, you get the value of that address. So in this program here, in this case, if you print age, it's the same thing printing the star and my pointer. All right, let's move on then. So if I can get the value, then most likely I can modify the value. So if I set the value to be, let's say, 100, and if I print the pointer, I'm going to print 100 now because I modified the value of where the pointer is pointing to. So it was 21, then I changed the value of where the pointer was pointing to 100, and if I display the my pointer, it displays 100. But now, if I display the age again, then the age got changed because the pointer was pointing there, and I changed the value where the pointer was pointing to. So what I'm trying to show you right here is that if you have the address of a given variable, then you can modify the value of that variable. In this case here, we created a pointer that points to the variable age, and then I changed the value of the variable age using the pointer. And that's because the age points to this location, and then once I create the pointer, I'm pointing to the same location where age was pointing. So I have something like this. So both age and my pointer, I point to the same location. So if I change the value where the pointer is pointing to, then it will reflect on the age variable here in this case. And the my pointer variable can be reused for other things as well. So let's say here I'm gonna create an int x equals 100, and then I can reuse the same pointer and now point to the address location of x. So that is totally fine as well. So what happened here is that now I have a variable called age, and then I have another variable called x, and x has 100. And here my pointer was pointing to age, but then once it came to this line here of code, then my pointer was not pointing to age anymore. My pointer started to point to the variable x. Now let's take a look on pointers and arrays. So I'm gonna delete everything here, and then I'm gonna create a array. All right, so here I have a array of integers, and I have 1, 2, 3, 4 values on this array. And if I want to display, let's say, the value number 20, all I have to do is put the index of 20, which in this case is 1. And if I use the index of 1, which is 20, I print the 20 right here on this screen. All right, so this is an array, and this is how you access the values in an array. Now, what if we use a pointer to access the values of an array? Can we do that? Absolutely. So let's create a pointer. And now I want to set this pointer to some values. Now, when it comes to arrays, I can point the pointer directly to the array. Remember, if this was an integer, I could not do that. I would have to put the ampersand sign here to get the address. However, when it comes to arrays, this is the address of the first location. And this is why you need to give the index in order for you to access the first, the second, or third, or fourth elements of this array. So this is already the address of the first location of the array. So if I just print the pointer here, I'm going to get the memory address of the first elements of the array. Now, if I put the star here, now I can get the value where the address is pointing to. So I'm getting the value, not the address. If I run this program now, I want to get that the value is now 10, which is the first location, which is actually 10. And again, that's because some values is actually the address. When it comes to array, the name of the array is the address of the first element. Okay, cool. Now, what if I want to print, let's say, the third element? The third element happens to be 30, and the index of 30 is going to be 0, 1, 2. So I need to move my pointer 2 locations. So in order to move my pointer to 2 locations, I'm going to get my pointer, and then I'm going to add 2. So now pointer 2 is pointing to 30. And if I want to get the value of 30, I put a star here. And then I get the value of the third element, which is 30. So I run this program and I get 30. And if I want to get the fourth value right here, guess what? I'm going to get 40 because 3 is the third element, and the third element happens to be 40. So here I get 40. And now one thing that you should be asking yourself, what if I have 4 here? There is no index 4. So what happens if I get the 4? Can I do the 4? Yes, you can. However, you are now access a memory location that only God knows what's in there. So this here is garbage. All right, so I'm going to leave this array here, and then I want to create now a function, and I want to pass some of these values to the function. So I'm going to create here a void do something function, and this function is going to receive a pointer as a parameter. And now I'm going to create a value here, int age equals 21, and then I want to call the do something function, and I want to pass the age. So now I'm passing the age to the function, and the same thing I did before, I can display the value where the pointer is pointing to, and if I do that, I get the value 21 here. If I don't use the asterisks, I'm going to get the address, but in this case I want the actual value. Now, because I have the address of the value, because remember here I'm passing the address, so because I have the address of that value, if I change the value using the address, using the pointer, then this value gets changed all over. So let's say this is inside the function, and then here I want to print something similar but in the main, and I want to print the age before and after calling the do something function. So I create a variable, then I just display what the variable is, then I call a function and I pass the address of that variable to the function. The function displays a value, changes the value, displays again, then you go back to the main and displays the same variable again. So let's see what happens when I do that. All right, here's what happened. So in the main function, I had the age, which was 21. Then it went to the function. The function printed the asterisk value, which is 21. Then I changed the value, and then the value changed to 100. And then once I go back to the main, the value that I set inside the function retains. And the reason why this variable got changed is because, again, I'm accessing the variable through its address. So every time I use the address, I have access to actually change the variable. All right, so now instead of passing the int age as a parameter, I don't want to do that anymore. I want to pass the integer that's inside the sum values. Right here, I'm going to create a pointer called PTR, and I'm going to set this to sum values. And if you remember, sum values is the address of the first element in the array. And right here, I want to print the PTR, the pointer, but the value that I'm pointing to. Then I'm going to call the do something, and then I'm going to pass the PTR, which is my pointer. And then once I come back, I'm going to print the pointer again, and I want to see what's happening there. So now here on the do something function, I'm passing the same integer pointer. Now, I did not do any modification on this function, because when I pass one pointer to the function, it doesn't matter if this pointer is pointing to a single value or if it's pointing to the array. All it matters is that it's a pointer. So since I'm passing a pointer right here to this do something function, the same way I was passing a pointer before, then the way the parameters are set does not need to be changed. But now here inside the function, I just display again the value where the pointer is pointing to, and then I can either change the value or I want to move this value one element to the right. So I'm going to put a plus plus here. When I do a plus plus here, all I'm doing is getting this pointer here, which was pointing to 10, and then once I do the plus plus right here, I'm walking this to the right, so now the pointer is going to be pointing to 20. And then finally I display again, so this should display 20. So let me run this program, and here's what happened. So on the main, I display 10, which was the value from the some values first parameter. Then on the function, I display the value again, which was still pointing to the first element, which is 10. Then right here, I changed where the element was pointing to. I just moved the pointer one to the right, so now I'm pointing to 20. And then I display the value where this pointer is pointing to, and it displays 20 right here. And then once it goes back to the function, the pointer is pointing to 10 again. Now this is a little bit confusing here, because if I changed where the pointer was pointing to, the first thing that comes to mind is that once you go back to the main, then the pointer right here on line 14 should be pointing to 20, but it's not. It's back pointing at 10. And that's because you did not change the pointer, you just changed a copy of the pointer, because you're passing the pointer right here not as a reference. You're passing the address, but not a reference to the address. So if you want the pointer to be changed after you finish executing this function right here, you need to pass the pointer as a reference, not as a copy. So in order to pass this pointer as a reference, I need to put the ampersand here and also the ampersand right here. And then doing so, I'm passing the address as a reference. So now it's a reference to the reference. And by doing so, whenever you change the actual place where this pointer is pointing to, that change will be reflected right here on the main as well. So now, if you take a look here, my pointer is 10. So it's 10, 10, 20, and 10. Just pay attention to 10 here. I'm going to run this program again, and then this value here will be changed to 20. So now this value got changed to 20, and the reason is because I'm passing the pointer as a reference. So this ampersand means reference. So if I change the pointer here, then the changes that I did here also are reflected on the main. I know it's a little bit confusing. All right, so I did this using integers, but I could also use a string. So I'm gonna change this really quick here, choose strings, and then we're gonna run this program one last time before we finish this video. So I'm gonna use a string here, some values. And now instead of using integers, I have to use a string. And then finally on the do something, I cannot use a integer, I have to use a string. So I'm gonna pass here a string. And then right here on the function implementation, I'm gonna do the same thing, pass a string, strings. And now if I want to display just one value, I'll display strings, and that will display the please alone. All right, that's good. Now I can do display this 4 times, but then on the second time I can add 1, and then on the third time I can add 2, and I can add 3. And now if I run this program, I get please like and subscribe. All right, but if you notice right here, the first one is the same thing of adding 0. So I can add 0, 1, 2, and 3, and I get the same value. Please like and subscribe. Now, every time I have a sequence of numbers like that, 0, 1, 2, 3, that looks like an index for me, and that just drives me to think about a for loop. So I'm gonna write a for loop here, and I'm gonna put a length of 4, and then instead of printing every single one of them like that, I can put everything in a loop right here, and instead of putting a number, I'm gonna put the index I, and then I is going to move where the pointer is pointing to. So now if I run this program again, I get the same thing. Please like and subscribe. And the beauty of doing this is that if I have, let's say, an array of 400 elements, for example, I can display every single one of them inside a loop like that without changing much of the code. All right, so that's all for this video. Thanks for watching.